this graph, you'll see that this is a position versus time graph, and there are some values along the axis. So the first question asks, what type of motion is this? And to be clear, we want to first address what can we get off of this. Well, position, where it is using the values on the y-axis. So we know that it moves from 0 to 5 meters in a little over 10 seconds. But what type of motion means, is it at rest, increasing, decreasing, or constant speed? So the slope of a position versus time graph is the velocity. So if we could talk about the slope, then we'll be able to talk about the velocity. So if this has a constant slope, because it's a straight line, and it's in the positive direction, positive slope means constant positive velocity. So we've got the physics in here plus the answer. I did that again. How far did the object travel during the 10-second interval? It went from 0 meters to 5 meters. Therefore, the displacement, or the distance, is 5 meters, right? Because this is the end. What was the acceleration of the object? When moving at constant speed, acceleration is always 0. Draw a velocity versus time graph. Okay, so now let's bring in the other type of graph. So first start by labeling the axes. So this is time in seconds and velocity in meters per second. This is a velocity versus time graph, so I need the value of velocity. Now I can calculate that because I know that the slope is the velocity. So I'm going to take a moment and I'm going to calculate it by finding the slope of the xt graph. So that's going to be the change in position over the change in time. So 5 minus 0 over 10 minus 0 is going to be 0.5 meters per second. So if I say that this is 1.0 and this is 0.5, and then this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, then for that whole time, that all 10 seconds, we're moving at 0.5 meters per second. And that's your corresponding graph. A rock is thrown down with an initial velocity of 4.7 meters per second. So let's draw that. VYT, VYT, acceleration. So the initial velocity is 4.7. And we can say that up is positive. You can make your y position 0 at the bottom or 0 up here. I'm going to make mine at the bottom. So this is what I'm looking for. Initial time is 0. And we want to know the final time is given. It's 2 seconds. And we know it's in free fall. So this is 9.8 meters per second squared. And if velocity is down and acceleration is down, then acceleration is going to be negative. That means I need an equation that has everything except for velocity. So that equation is this one. So this is what we're looking for. We're looking for y2 minus y1. That's what displacement is. V initial is 4.7, time is 2. This is negative 9.8 and time is 2 again, but it's squared. y2 is 0, so that goes away. We've got negative y1 equals 4.7 times 2 is 9.4. Oh, and this is, look, these are both negative, so you have to make this a negative number as well. Don't forget that. The other term, 0.5 times negative 9.8 times 2 squared, that's negative 19.6. And then you can add these two numbers together, negative 19.6 plus negative 9.4. Now notice, if you forgot to make the velocity negative, then you would actually then have like 10.4 as your answer. The negative signs actually do matter. So your initial position is 29 meters. So this is just reviewing the problem solving that we had done. And now we're going to add this to our graphical analysis, right? Making graphs. So I'm going to make a VT and we're going to make a position time graph. So this is our this is going to be our Y position. This will be time. This will be velocity. And this will be time. So we know we've got 2 seconds. Let's do 1, 2, 3, 4. That's 1, 1, 2, 3, 4. That'll be 2. So this will be 1, 2, 3. Let's do that. Just trying to spread it out a little bit. You could probably make it 5 if you want to make each one 0.2. I made each one 1/4 second. And then the total distance, I need 29 meters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I can make each one 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. All right, so you make your scale when you have numbers. And now we know that in 2 seconds, we know it starts at 29 meters. So up here. And it ends at 2 seconds. It's back at ground level. This is increasing speed in the negative direction. So we have to get steeper and steeper as we go towards the ground. So then you connect those 2 dots. For this one, we're starting at negative 4.7. So let's say 1, 2, 3, 4, 5. You know what? We don't know the final velocity. We didn't need to find it. But you know what? I would like to find it so that I could use it in my graphing. So I'm going to do a quick calculation here. And just, you don't have to do this. I just like to be precise. If you have time, it's a good thing to do. So this is going to be negative 19.6. So 19.6 plus 4.7 is negative 24.3. So that helps me out here because I know I've got to do negative 5, negative 10, negative 15, negative 20, negative 25. And I'm starting at negative 4.7. So let's say that's like here at 0 seconds. And then by 2 seconds, I'm at 24.3 meters per second. And this is increasing speed. And remember, we don't have curves on velocity time graphs, so we're just going to connect them with a straight line. That's what this graph looks like. Now, let's say you didn't have time or you didn't think of calculating the final velocity to figure this out. Don't worry about it. Just make sure you put this in the right direction. Last question. You're given a graph, and this is actually from Capstone for the actual motion of an object. And we're going to interpret this graph, the part that's highlighted, this yellow highlighted part. So it says, use the graph to identify the values. So what you're given is, here is the coordinate for point A. So the time is 0.450 seconds. The time at B, here's its coordinate, is 2.200 seconds. And then at point C is 4.100 seconds. The velocity at A, because this is a velocity versus time graph, right? Here's time, here's velocity, and they look at the units on the Y coordinate. The velocity at A is 0.734. At B is 0.002. At point C is negative 0.603. The acceleration for these is going to be the slope, right? The slope of a VT graph is acceleration. Therefore, we can use this value, negative 0.376 meters per second squared, right? They give you the slope with the linear fit. The change in time from A to B here, you can just calculate it's going to be final minus initial, B minus A. So 2.2 minus 0.45, that's 1.75 seconds. And from B to C is 4.1 minus 2.2, which is 1.90 seconds. The displacement of this object, you can do this a few different ways. You can either find the area under the curve, or you can do the calculation for it, given the initial velocity, the final velocity, and the change in time, and the acceleration. So for example, right, so method 1 would be using an equation. So you'd say that VA is 0.734 meters per second. VC is negative 0.603 meters per second. Acceleration is negative 0.376 meters per second squared. And now you can find delta D. So you can do that and like this. Oops. So that would be negative 0.603 squared, 0.734 squared, plus 2, negative 0.376 delta D. So let's go through it. 0.603 squared is 0.36, I'm going to round that to 4, and 0.734 squared, let me round that to 9, and then 2 times negative 0.376. Subtract this to the other side. And you get 0.233 meters. Now, what about method 2? You could do the area under the curve. So that will be this here, this triangle, and that triangle. So I will do the area of A to B equals 1/2. The height is 0.734, and the base is going to be the time from A to B. So that's 1.75. So 0.5 times 0.734 times 1.75, which is 0.642 meters. That's the displacement that happened here. And here, the area from B to C is going to be this height, which is from 0 down to negative 0.603, and the time from B to C is 1.9. So 0.5 times negative 0.603 times 1.9. Negative 0.573 meters. The displacement is adding these two together, right? That'll give you your total displacement of those two shapes. The sum of them is just 0.0692 meters. The next question asks for the distance traveled. Now the distance traveled does not take into account that this one is moving in the positive direction and this one's moving in the negative direction. You don't have to worry about it. So for number 5, all you have to do is take the area of A to B and add it to the absolute value of the area from B to C. We don't care about the negative sign. The total distance traveled is going to be 0.642 plus 0.573 without any negatives. So your total distance traveled is 1.2, because we know that this, you're traveling in the positive direction, and then you turn around and move in the negative direction. So the total distance traveled is all, like it's as if you had an odometer on you, and you could get that total distance you've run, even though you've gone back the way you came. The last one, number 6, asks if it could be a freely falling object. And the answer is no, because acceleration due to gravity is 9.8 meters per second squared, not negative 0.376 meters per second squared. So that's the easiest way to answer that question.